So we are just going to continue right along with factoring today. We are still going to be looking at trinomials. Okay, we're just going to take a look at another specific type of trinomial that we can factor. So trinomials are still 3 terms. But today we're going to look at trinomials that are specifically in the form x squared plus bx plus c. So while there is an a value sitting here, that a value is always going to be 1. And when that a value is 1, we have some specific things that come into play that make factoring actually a little bit easier. So let's say we are given the trinomial x squared plus 7x plus 12. Now, just like yesterday, we have to start off with that exact same sort of rule. So we're still going to have to take a times c. So in this case, a is 1, right? So we're taking 1 times 12, which is 12. And unfortunately, we can still not avoid listing all of those factors, those numbers that multiply up to 12. So 1 times 12 is 12, 2 times 6, 3 times 4. And we still want to find that pair that will add up to 7. Okay, we want it to add up to b. So 1 and 12 is 13, 2 and 6 is 8, right? But 3 and 4 gives us the 7. Okay, so we'll split this up just like we did yesterday. And then factor by grouping. And right now you're probably like, what? This is exactly the same. But right now it is. But we're going to see what happens here. So if I split this in half and I factor out a GCF on the left, I'll pull out an x. So that will give me an x, and then we'll get an x plus 3. And over here I'll factor out a 4, right, which will give me an x plus 3. And we'll put this into 2 binomials, which will be an x plus 4 and an x plus 3. And you might not think anything of it, and you might go, okay, that's exactly what we did yesterday. So yes, you can always do this exactly how we did yesterday. However, if we take a little bit of a closer look here, we will notice this 4 and 3, 4 and 3, 4 and 3, 4 and 3, right, are sort of this consistent pattern throughout. And what actually happens is we can avoid all of this rewriting and factoring it by grouping when a is 1, right? Because when a is 1, we know our GCF over here can only be x because there won't be a number in front, which will leave that number, which means the only way to make it match is we're pulling out the number here. And so we get those same numbers. Okay, so let me show you what it looks like with this common theme of these numbers. So let's say we have x squared minus 12x plus 20. Okay, so we're still taking a times c, so 1 times 20 is 20. And we list our pairs. 1 and 20, 2 and 10, 3 and nothing, 4 and 5. Now, we need this to add up to a negative 12. So when this is positive, but this is negative, we need both of these to be negative. Now, you can still use that list from yesterday, right? When we have a negative followed by a positive, we need them both to be negative. So we want our set that will add up to negative 12. So right here is our set that will add up to negative 12. But now that we know that a equals 1, and we know we have this pattern where these numbers show up all the way through, we can just go straight into 2 binomials, where we're going to use our variable, but without the exponent. We're actually taking half of the exponent, right? Half of 2 is 1. And then we'll just fill these numbers in the blank. So it'll be a negative 2 and a negative 10. And so our factored answer will be x minus 2 and x minus 10. Now, just like we've been saying, right, we could have that in flip-flopped order. So we could have that as x minus 10 and x minus 2. Okay, so how about we have y squared minus 12y minus 160. So big number here, so big list. So 160. So here we go. 1 and 160. 2 and 80. 3 and nothing. 4, right, you could use a calculator if you needed. 4 and 40. 5 and 30. Let's see, it goes on 32. 6 and, I'm going to start checking some here. Nothing. 7 and nothing, I think. 8 and 20. 9 and nothing. 10 and 16, right? I mean, we just stick out a list here. 11 and nothing. 12 and nothing. I think we're kind of done with our list there. 14, yeah. Okay, so, I mean, you could keep going, but you'd figure out that they're all nothing. We have a positive followed by a negative. So again, if we use that list from yesterday, we want the smaller one to be negative and the larger one to be positive. And we want our set that will add up to 12. So our -8 and our 20 are going to add up to 12. So again, A is 1, so we can go straight into 2 binomials where we're taking half of that exponent, so just y. Okay, then we'll have a -8 and a +20 as our factored answer.